No, I'm not obsessed with time. Time making, maybe. I got interested in wooden works by accident. When I was working down at the foundry as a salesman, a man came in whom I knew was a contractor, and he had some castings he wanted to make for a Joseph Ives wagon spring clock, which is kind of a rare clock. And the parts were so small, the foundry didn't want to fool with it. But he talked me into taking the job on my own. I made the molds, cast them, cleaned them, and I ground them up, and I called them up, and he came down after them. And when it was time to pick them up, I found out something about the man. He had short arms and deep pockets. He just didn't want to reach in his pocket to pay me. So what I did is I settled for what he said was a real surprise. He says, I'm going to bring to you a Wooden Works clock, case and all, as payment. So I got the clock. I was amused at how, and amazed how they were made. I took it apart, made the drawings, and I said, now I'm going to make them in production. In the beginning, as a machine designer and a draftsman, tool maker, and what have you, I kept looking at this as something that would be made in present day with machinery and cutting gears and stuff like that. And I finally had to, I realized that they didn't do it that way. They had primitive wooden machines with a very, very small amount of metal attached. A spindle, a cutter, maybe a pulley, and a leather belt. All the rest had to be out of wood. Now I'll be cutting them right here. There's a tooth all cut. There's another one already cut. So I have two blanks here. I already cut 4 teeth. And as you go around with rapid index, you do them all. This is pretty much the way they did it, with a file and a slide and back and forth, and then indexed it to the next one. This is an Eli Terry, a copy of an Eli Terry number 5, the famous movement that everybody copied. And the way that these holes are all located, today you would put them on a jig borer and with thousandths of an inch and you'd bore it out exactly. But in those days they didn't have that type of equipment. What they had was a template, and they would take this piece, put it in position, locate it with screws. Then they would take this little punch, and it would start out with the time train, and it had a little dimple on it. You'd punch that, pum, 2, 3, 4, 5, and you would go by the numbers, because if you don't go by the numbers, you don't know if you skipped number 3 or 4. And they go right back down through the whole works, punching out the spot where these holes are going to be drilled. Every one. When that is done, the plate is taken out. It wouldn't have these holes in. This here, I don't have a blank for now. Then it is then taken and put into a template, whereby the template will tell you which holes to drill and at what size. There was Hopkins and Alford in Thomaston, or it would be Howerton actually, had a patent on a 3-spindle machine for cutting gears, and he peddled that thing all over New England, all the way out to Ohio, and he had a patent that was very good, and he sold many of them, and not one of them has survived. There's not one machine to make wooden gears or pinions in any amount of production that's survivable today. So from that, I created these machines, which you will see in operation, or you'll be able to view them, and I feel that's how they made them. This is the machine we spoke about before, being about 100% metal versus Eli Terry's 100% wood. But it was easier for me to make it out of wood. It could be smaller and easier to handle. What I do here is this. I have the blanks pre-cut to the diameter needed. I stick them on. I can do as many as 14 of these at a time, but right now we're going to be doing about 6 or 7, being conservative. I put this on and I have a mechanism here that gives me the outboard support, and we clamp the whole thing into one big sandwich. That's to make sure that there's no rotation of the parts while it's being cut. Now I set on the motors, and I have what I call a rapid index here. By just pushing up the handle, it'll index it properly and lock it in position. Now I'm going to be cutting through the first slot. As you'll notice, I'm cutting them on different teeth. But as you get index around, everything gets completed. Very shortly, you will see a completed tooth. The operation of that machine is simple. One saw cuts the leading edge and the other one cuts the trailing edge. It doesn't necessarily have to be the other tooth. It could be 3 teeth behind. And then combined with this saw is the crown cutter, and as a combination, so that you get the trailing edge, the crown, and the leading edge cut all at once. Cutting of the pinions and wheels and turning is all machine work. Yeah, right. The handwork comes in the sub-assembly and assembly. As an example, I have 100 plates, which is called the rear housing and front housing for the shelf clocks, and I have parts for the internal parts for 100 of them. Now those are sub-assembled. The pinion is assembled to the gear and so on and so forth, and they're all labeled in a box, and it's actually not much of a job putting it together because everything quality control that, and once you put it together, I usually put just the timekeeping side train in. It's a test stand that I'm testing the parts from the boxes that I have and the plates that I've pre-finished. I put in the time train first with a motion train, and I wait to see if everything is operating properly. If I have to make any adjustment, it's easy to remove the parts, make the adjustment, and put it back together. The strike train, which is on this side, usually doesn't give me any problem, so I don't bother testing that separately. However, with my hearing the way it is, I've got to use an amplifier to listen to the tick, and the tick tells me an awful lot. If that works, I'll go to adding the motion train, which is the one that operates the hands. When that's done, I take a gamble and put in the strike side, which is not as critical as the other two, because that's soon as your strike signal sets off, she'll go like a rabbit, you know. This is a model of or exact copy of the Silas Hoadley 30-hour tall clock movement. It's time, strike, seconds, and calendar. This is the rear side of the 30-hour tall case clock. This is the count wheel. This diameter is divided into 78 parts, which is the numerals of the dial added together, so that one slot is equal to 1/78 of the circumference. That diameter that is not slotted prevents this little detent from dropping, and every time this detent hits that diameter, it will ring. But once it comes to the slot, it'll drop in and stop the motion. So I'll show you now. It's going to ring 11 o'clock when I get around to tripping it. This little lever raises, cocks the circuit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, stop. The next one being longer will give you one slot width more. It'll be 12. On the engineering drawings that I made, I started to make them because I can't work without instructions. And even if I have the instructions made by myself, at least I know what to follow. And if anything goes wrong, I'll know where to correct it. And that has been a great help to me. And I have made engineering drawings for 30 or 40 American Wooden Works clocks, anywhere from the 30-hour to the 8-day. And from the count wheel type, strike, to the rack and snail type. And I can just imagine people hearing about Joe Blow down the road of 5 miles, just bought a clock. They would go visit him, sit down and watch it and wait for it to ring the hour. I mean, that was really a joy to watch.